Hi, my name is Hajime Sugiyama from Mitsubishi Electric, and I'm an industrial IoT evangelist. Today, I would like to talk about the topic of data analytics in manufacturing. Data, data, data. I'm sure you hear a lot about data from your bosses right now. You have to use data. You have to use AI in our factories to improve our manufacturing right now. Please show me and do a project to show me what you can do with data. And a lot of people that I know get homework from their bosses and come to me for help right now. So it's not an easy job, but we have to do it. So today's presentation, I'm going to try to give you an introduction of how you should do data analytics in your factory. When you start a data project, this is the most important question you should ask yourself to start out with. What is your goal? Is your target to shorten lead time? Is your target to save energy? Is your target to improve your operation equipment efficiency? This is a question you have to ask first. The reason you ask this question is the data you will collect totally depends on your goal and is totally different. It's not even the kind of data you collect or where you collect it, it's the frequency will be different. It's the timing will be different. And everything will depend on your goal. It's really difficult to just gather all the data you can and solve your problem. The data you're collecting is always associated to your goal. So that's why we say, okay, let's first define what we want to get out of this data analytics project. The second thing we also say is, please pick a problem in your factory, and the more specific the better, that you want to solve right now. The reason we say it's better to solve a problem is because you're going to need the help of your workers in the factory, your fellow engineers in the factory. The engineers that are working every day on their factory lines are very busy. They have to start up a line that is not working right now. They have to make double the output this day because they got a big order, and they really don't have time for helping you out with data analytics. In order to get the cooperation of your fellows, it's better to have a problem that they want to solve, but they can't solve because they don't know the answer to it. So if you can say, okay, let's do this project together, and by using data analytics, we will be able to solve your problem, I think you will get more cooperation from your staff. Data analytics has a huge potential. Just look at the numbers we did in a Malaysian Intel plant right now. They had a problem with the test machine, and they couldn't solve the problem, but with edge computing and with data analytics, we were able to solve the problem, and we're saving $9 million a year with data analytics. So if you can find the right specific problem and you can solve it, the potential is huge. During this presentation, I would like to kind of go through how a standard data analytics project would work like. So you would first set your goal, then you would collect your data, then you connect and select the data, then you do data analytics, and then you do diagnostics right now. To make it easier, I would like to use an example. So this is a gearbox right now, and we have this red gear in between. That sometimes wears down and then stops the machine right now. So we want to monitor this red gear's wearing, so we can find out when it's going to wear and affect the machine, break down the machine. If we can know it up front, then we can stop it, then we can do the maintenance, and we will have no problem with production right now. But actually finding out when this red gear will wear is very difficult. It's because we can't put a sensor here, like another standard application right now. It's because the gears, they smash against each other. If you put a sensor in between it, then it will crush. So there's no way to find out, if this gear is wearing down or not. Also, you have to disassemble the entire gearbox to find out the status right now. So, okay, can we use data analytics to solve this problem? The first step is to collect and select the data you have. So we don't know the gear wear data, the status, but we know a lot of different data. We know the environment data, we know the gear strength data, and we know the electrical characteristics of the motor. We know even more detail, like the humidity, the ambient temperature, the material type, the shape of the gear, and also lots of data surrounding the motor, the current, the speed, and the temperature. This is why it's very important to involve an expert, meaning an expert, not a data scientist, but more the guy that actually knows the machine the best on the factory floor, because you will be involving data scientists in your project, but they have never touched the machine that you want to solve right now. They've never been in a factory, a lot of them right now, so they will not know what data is necessary to solve a problem. And that's where you need the expert who is handling the machine every day right now, who has this kind of hunch that sometimes the temperature is the most affects the application, so you should take the temperature data, or the motor speed, because it's very fast, it affects the gearbox, so you should take that data. Involving the expert, you will get the data you need to select and use for the project. Then we'll go to the data analytics phase, and it's basically data trends, cleansing and selecting, analytics and algorithms, and diagnosis and modeling. I'll go into detail. At the end for the gear wear, your goal is to make a chart. So the gear goes up, it wears down, and eventually it will break, become abnormal right now. You want to find out the point where it's not breaking, before it's going to break, the turning point right now. And if you are able to define the turning point, then you will be able to stop the machine, then disassemble, and maintain the gearbox so it doesn't break right now. So this is the ultimate goal of this gear wear project. First, you collect all the data you think is necessary, and then you do data cleansing. So data, when you receive it, is not necessarily in the format you want. And for instance, a lot of it has noises right now. So cleaning up this data, taking out the noise and relevant data is very important. The other thing is removing data when it's not operating right now. So there's no need to collect data when the machine is not running. So throw out all the data when it's not running right now. Just use the data you can. This is very important to throw away data, because the more time, the more data you have, the more time it will take to do the data analytics. And if you have a lot of irrelevant data that is not associated to the project, that's going to add some more computing to your project as well. So in order to shorten time, it's important to throw away all data you can. The next phase is selecting the data that is relevant to the gear wear. In this case, as you know, the gear wear will go up. It's wearing down every day, so it's going up in this kind of trend chart over here. If you look at the other data you have, for instance, around the motor, you see the current, you see the torque, you see the rotations per minute, and you see the motor temperature. For instance, the current is a straight line. The gear wear is moving, but the current is straight. This means that probably this current data has nothing to do with the gear wear. In that case, you throw it out. But the other data is moving around, so it might have a relevance to this gear wear. So let's keep it and use this data to analyze projects. As I said, selecting the data that you need is very important, and not doing everything. Then you would kind of select the analytics algorithm necessary. This is where you should involve somebody who is good at statistics right now, because the method you will select, and there's various methods to select, will depend on the kind of data, the type of data, and the variance of data you have right now. So if you're collecting waveform data, then it makes sense to use this kind of similar waveform recognition methods. And the other methods would depend on, is it fluctuating data, are there many different types of data, then you would kind of select the most relevant analytics method to do your data analytics. One important thing you have to understand is that the virtual world, the offline world, and what you're analyzing, the PC, might be different than the real world, your actual machine. You cannot replicate everything that's happening in the real world in a computer. There's lots of things that it's not a 100% virtual world in a computer. might be something different, or the model you're making, might be something altered from the actual world. That's why it's important. Of course, you can make the model in the offline, in the cloud, in the virtual world, but you should check it actually in the real world to see if it's actually the result or the condition is happening in the real world right now. So this offline, online comparison, test and trial, is very important. After doing the data diagnostics, we found out, for instance, that the temperature and the current and the acceleration patterns of the motor was most relevant to the gear wear right now. So in this case, we took these three data and we kind of made a predictive formula saying that, okay, temperature is this A, current is B, acceleration is C. We put some multiples, and then we will be able to find out the gear wear right now. So we make this predictive formula, and also we create a threshold. Threshold meaning, if the gear wear rises to a certain level, then we want to send out an alarm to alert the worker to stop the machine right now. So these two we create, and we actually take this predictive formula and test if it works. So I put this in the actual machine, put it in an edge computer, collect the actual data, then produce the chart. Okay, here's how the gear wheel should look. And while we're doing that, sometimes we even stop the machine, take out the actual gear, and compare it to our predictive formula to see if it's actually the same as we predicted. If it's not, then we will tune, we will do adjustments and try it again right now. So this kind of refining process, combining the virtual world and the real world, is very important right now. And it takes a lot of time to do this. Okay, it's finished, we're fine, now we can do predictive maintenance. It's correct, but you have to kind of remember it's not over right now. Okay. It works for one machine, of course, but alerting is not enough. You should make the PLC program to stop the machine when that alert happens right now. Can you pass this model on to other machines, similar machines? Yes, maybe production lines. Yes, maybe you can copy it, but you should test again. Because as I said, everything is not the same in simulation. And even this line C and this line B, there might be some differentials. Maybe it's 1 degree diagonal or something like that. But that would alter the entire data patterns right now, and probably the predictive formula and thresholds will differ right now. So it's important to take this program and also test it over here to do a reality check right now. If you change the product, you would have to go through the same sequence again, because the data you're collecting will not be useful in that new application. So it's a never-ending process of refining the data, checking if it's okay. One important aspect of edge-based analytics is that it's done in real time. A lot of people have the image that you're doing data analytics in the cloud right now, and then this supercomputer takes the data and tells you the answer. Of course, if you're working in the internet, for instance, on your PC, Google Analytics can do that in seconds or minutes right now and give you an answer. But that's not good enough for the manufacturing plant. Google, Apple, and Microsoft work in seconds right now. But on the manufacturing world, we work in milliseconds. In milliseconds, we're using the data to kind of drill our machines or process machine tool parts. And if something happens, it's not going to happen in seconds. These trends are going to happen in milliseconds right now. So the data we're gathering is in millisecond level, which means we're gathering 1,000 times compared to your standard PC, and sometimes more than 10,000 times the data. Do you have enough time to process the data and send it up to the cloud and get an answer back? Probably not. And that's why we say edge computing, edge-based analytics is so important. Having a computer, edge computer, near your actual application that can take the data, process it, analyze it, and give back the feedback immediately. If you're machining a $10,000 part right now, you need to stop it the minute you find something wrong. You have no time to communicate to the cloud. And that's why this kind of edge computing is so important. If you look at the data analytics world in manufacturing, you're checking these kind of waves in milliseconds right now. So even if you have this super cloud-based AI, you're not going to have enough time to talk to the AI in the cloud and see if it's good or not right now. And that's why it's important to have edge-based AI as well right now. And as Mitsubishi Electric, as we know the importance of edge-based analytics, we are actually developing AI that works on edge computers, so you don't have to communicate through your networks all the time when you're doing data analytics on the manufacturing floor. And the minute that millisecond bad wave comes, you can detect it. This is an excellent example of our monitoring. You see, white turns to red, it found out something went wrong, and this is where everything's working in milliseconds, but we're doing the comparisons with the AA on the edge and collecting the data through the edge computer. It only works this way. You have no time to connect to the cloud. Next, I would like to go through an actual use case of data analytics in manufacturing. This is an example that happened in an electronic plant for manufacturing right now. What it's doing, it's actually coating this electronic chip right now. So this is a vacuum chamber, and what it does is the final chip is on the top, there's the coating material over here. It puts a beam to it, and the coating material will melt, and then because it's a vacuum chamber, the material floats, and it sticks up to the product, and the product is coated right now. So this is the application. What our customer in this case wanted is he wanted to do mass production without doing a pretest, because they were doing pretests for mass production before this data project. So what they did is, when they wanted to start a lot of production, they'd first take one part, put it in the chamber, then produce the part, take it out, do a quality check, and then see if it's okay or not good. If it was okay, they would go exactly into mass production. If it was not good, they would clean up the chamber and make sure it was okay, and then go to mass production. But the issue was that, they felt that this pre-testing procedure was a waste of time. Because probably if a product was good or not, the manufacturing process were good or not, depended on the characteristics of the chamber. If the chamber was clean, what was the exhaust time, how much time did it have to have with clean air, these kind of environmental parameters. If they could collect those kind of environmental parameters and analyze them, they would find out if the product was good or not before they went into mass production, and therefore get away with the test phase. So they asked us for help, and we worked together on this project. There's two also special requests that they have. First, they didn't want to alter the machine because it was a very delicate machine. So they said, and when you do data analytics projects, sometimes you have to change the sequence, PLC programs, in order to collect data. They said they didn't want to touch the original PLC program as much as possible, so they wanted to do an external edge computing solution to it. The other thing is they wanted to use off-the-shelf, easy-to-use software. And they didn't want to involve so many data scientists in the project. For some reasons is because involving data scientists make the project very expensive. And the other thing is they wanted to learn to do it by themselves right now, because in the future, they predict that they will be able to use data a lot in order to solve their manufacturing problems. So they wanted to use this as a practice case. So we tried to help them out, and we started the project. First, we said, okay, what data we can collect? And actually, we found out there were 60 parameters involved in the environment of the chamber. This is where it is very important to involve an expert. A data scientist would have never told you what kind of parameters are around this vacuum chamber, but as we were working with the experts on the factory floor, we were able to collect these 60 parameters. We did some data analytics, and we found out that actually only 3 decide the quality. And this was very important because we were able to throw away the other 57 parameters and just work on these 3 parameters to refine the calculations right now. The 3 parameters were the pump exhaustion time, the open air time, and the cleanliness of the cubicle. So we took those parameters and we made our prediction calculation that you see over here. After we did the calculation, we refined it. We went to the actual machine to see if our predictive calculation was right or not. And then we did the fine-tuning to get the result we needed. And then we went online. So right now, before we start mass production, we gather the data, the pump exhaustion time, the open air time, and we feed it to the edge computer. And exactly, instantly, the machine, the computer will tell us it's good to go right directly to mass production, or it's not good, so you should adjust the vacuum cleaner. And we were able to throw away the pre-testing phase. So you can see the results, It's a big reduction in lead time because we don't do the pre-testing, and it saved them up to 360 hours of machine operation time, and about 36 million yen year saving right now, which is a big benefit. And remember, this is only one machine that we're talking about, so if they could do the same for other machines, every machine they would be able to save this many times. So, great project, and it worked out for us. One final advice I have to us is, data analytics is not easy. From my experience, there's a lot of times that you don't even get the result that you expected, so you just throw away 3 months of your time. So it's not easy, and you have to be prepared for that. But because it's so difficult, you should use the experts around you. There's a lot of system integrators that have knowledge about data analytics, and a lot of data scientists that you can use for your help. You should use them effectively. Another good option is to use smart products, AI that is embedded, data analytics that are embedded easily into the product, For instance, we have a vibration sensor over here, a smart vibration sensor, which you just stick it on a motor, and then you monitor it for 10 minutes, and it finds out the characteristics of the motor. If something is altered, or something is wrong, it will send out an alarm to you. It's very simple. You're not doing data analytics on your side, the sensor does it for yourself. So you don't even have to hire a data scientist in these cases. And I think as Mitsubishi Electric, we're trying to kind of implement this kind of easy technology that is embedded in our components. So that's the end of my presentation. Just a summary of what we're talking about is, first, it's very important to set your goal, because the data you'll collect will totally different. Always involve experts, edge-based analytics for the response time. And also, don't forget the option of using smart components and partners. I hope this short presentation will help you enter the world of data analytics. And if you have any questions, feel free to come to Mitsubishi Electric. Thank you very much.